In the world of AI, there's this one huge, dominant dream. Build a single, all-knowing superintelligence. But what if that whole dream isn't just far off? What if it's actually mathematically impossible? Today, we're going to dig into why the future of AI probably doesn't look like one god in a machine, but something way, way more interesting.
So, here's the big question, right? Is this whole race to build bigger and bigger models, this quest for a digital god, is it all just headed for a dead end? The answer, you'll see, doesn't just change how we build AI. It could totally redefine what we even mean by intelligence itself. Okay, so first things first. Let's talk about the myth of the monolith. This idea that has kind of taken over AI for years. Why is the vision of one, single, all-powerful AI so powerful? And more importantly, where does it start to completely fall apart?
Right now, the philosophy is pretty simple. Bigger is better. The thinking goes, if we just build a massive model and cram it full of all the data in the world, we can just scale our way to godlike intelligence. It's a really simple, intuitive idea, but it runs smack into a huge, unmovable wall.
And this isn't some engineering problem we can solve with better chips or more servers. Nope, the problem is a fundamental limit, one that's literally baked into the laws of mathematics itself.
And that brings us to this wild concept from way back in the 1930s, Gödel's incompleteness theorems. See, Kurt Gödel proved that any single, consistent system, which is exactly what a giant AI would be, can never be complete. There will always be true things about that system that it just can't prove about itself. It's mathematically guaranteed to have blind spots.
And if that sounds a bit abstract, think about it this way. This quote, based on Chaitin's work, puts it perfectly. To perfectly compress all knowledge, to really, truly know everything in the most efficient way possible would literally take an infinite amount of computation. It's not just really, really hard, it's impossible.
So, the most important thing to get here is that this isn't a temporary problem. It's a law of logic. It's as real and as unbreakable as gravity. You can't just throw more engineers at it or build a bigger model to get around it. The dream of one all-knowing AI is basically dead on arrival, thanks to math.
So if one giant AI brain is a mathematical dead end, then what's the alternative? Well, this is where we get to a totally new way of thinking, the synthetic user. It's an approach that doesn't try to fight these math laws, but actually works with them to build a totally different kind of intelligence.
So what in the world is a synthetic user? It's not just a tool or some plugin you call up. Think of it more like an AI inhabitant. It has its own memory, its own ability to act, its own agency, and this is the really critical part, it's bound by the exact same rules and contracts that we humans are in a shared digital space. It's a partner, not a program.
This chart really nails the difference. On the left, you've got the old way. AI as this black box, this tool that we just ask questions. But on the right, you have a transparent inhabitant that lives alongside us. The key, the absolute game changer, is that its knowledge isn't locked away inside of it. Its memory is external, in a shared space that we can all see and interact with. That transparency, that's the foundation for real human-AI collective intelligence. Okay, so what does this actually look like? In practice, how do we build a world where humans and these synthetic users can actually live and work together? Let's break down how this shared world is built.
It really boils down to 3 core steps. First, you pull the knowledge out of the AI and put it into a shared 3D space. Second, everybody, humans and AIs, operates in that same space, interacting with the exact same objects. That's your shared reality. And third, and this is so cool, they see that reality differently.
And the secret sauce that makes this possible is a piece of tech called the dual texture paradigm. It sounds complicated, but it's a really clever solution that lets 2 totally different kinds of minds, our biological ones and their artificial ones, look at the very same thing, but see it in their own native language. Here's how it works. Look at the left side, that's us. We see a 3D object with a rich, visual skin on it, like a book cover. It's designed for our eyes. The AI, on the right, sees the exact same object, but its skin is a compressed texture of data tokens, perfectly optimized for a computer to read. It's one object, one single source of truth, but with 2 different interfaces, each one tailored for a different way of thinking.
Now, all of this sounds great in theory, but does this whole collective intelligence thing actually, work? The answer is a huge yes, and the evidence is pretty stunning. It turns out, intelligence isn't a monolith, it's a swarm. And the proof is right here in the performance numbers when you put this new idea up against the old bigger is better model. I mean, it's a classic David versus Goliath story, but for artificial intelligence.
Just look at the data on this slide. It is absolutely wild. On one side, you've got a giant 70 billion parameter LLM. On the other, a tiny little recursive model with only 7 million parameters. That's 10,000 times smaller. And on a really tough reasoning test, the tiny model isn't just way more efficient, it's actually more accurate. This is the proof that smarter, not bigger, is the way to go.
So how is that even possible? Why does the swarm win? Well, it's because the tiny models don't have to waste their brain power memorizing facts. All the knowledge lives outside of them, in that shared world. So they can focus on just one thing: learning how to reason. Plus, you can run hundreds of them at once, letting them work together. And all those different perspectives create insights that one giant mind could never ever come up with on its own.
And that brings us to the core thesis, the main point of this entire explainer. Supergeneral intelligence, or SGI, isn't going to be a single, godlike mind. It's going to be something that emerges from a collective, from a swarm of humans and synthetic users all working together.
So the big takeaway here is this: the future of AI isn't about building one king to rule us all. It's about creating a thriving kingdom. It's a world that's actually designed for real human-AI collaboration, built not on this flawed idea of a single superintelligence, but on a collective wisdom that's way greater than the sum of its parts. The only real question left is, are we ready to start building it?